There are a number of formulas in the study of probability that we can actually develop quite intuitively by using tree diagrams. So sometimes when we calculate probabilities of individual events, we have to use counting techniques. And I'll give you an example of that. And other times, probabilities of individual events are already given. So we may already know the probability of an event that may be provided to us. It might be, say, 0.36. And then we want to use that to address further probability questions. So what I'm talking about here is in counting problems, let's say that we generate a random integer between 1 and 12 and want to know what's the probability that this random integer is divisible by 4. Well, so we know that between 1 and 12 there are 12 different integers, and assuming that we're selecting one of those with an equally likely chance, we need to count how many are divisible by 4. Well, anything that's a multiple of 4, i.e. 4, 8, and 12 are all multiples. So this would be kind of like what we would call our event, or the set of possible outcomes where we would get what we desire. And then the sample space would, of course, be the integers 1 through 12. And so we would say that there are 12 possible outcomes in the sample space. 3 of them are the ones that we would like, so there's a 25% chance that happens. Okay, so we had to compute that probability, but in the problems that we're going to focus on here, we're going to suppose that the probabilities are already given to us. And we're going to investigate. We've already seen an instance of probability of joint events where we want one thing and another thing to happen. And just as a reiteration of that, if we wanted a formula for it, the probability of A, we write it as A intersect B, which just means the probability of both A and B occurring is equal to the probability of A times the probability of B, provided that they're independent events. Independent events. Okay, and so that just means that we're assuming that the likelihood of B occurring is not affected by the first event that occurred. So maybe the likelihood of a storm in California is probably independent of whether Intel's stocks have gone up or down. And therefore, the likelihood of the stocks going up or down would not be affected by there being a storm in California, somewhere in California. Then we're also going to look at the probability of the union of events, which is one or the other. And we remember that when we're working with sets, it's A union B. Now, we're not really going to work with sets here, but I just want the formulas to emerge out of an understanding of what it actually means. And then the probability of at least one thing happening. So maybe we want to know what's the probability of getting at least one day of rain in, say, 2 weeks. Okay, let's take a look at an example. A credit card company finds that 12% of its cardholders make a late payment in any given month. It further finds that 25% of its cardholders are from one of the 4 corner states, so Arizona, Colorado, New Mexico, and Utah. The likelihood of a late payment seems to be independent. Okay, there it is. So the likelihood whether or not somebody makes a late payment probably is independent of what state they're from. And that will allow us to multiply probabilities if we want to know joint probabilities. Now, it's always nice to use a tree diagram because especially when we have one of 2 possible outcomes for either a late payment is made or the payment isn't late, and then the other event is the likelihood that they're from 4 corners or not from 4 corners. We don't know what area they're from if we say not 4 corners, but we're going to break it up into like a binary split. It either is or isn't. And that allows us to always allow people to funnel into one group or another. So I'm going to start off with a tree. Let's imagine that we have a bunch of people lined up. Okay, you can appreciate my art here. And we have a bunch of people, ... Perhaps we have, maybe 100 people. And they enter kind of this path, right? So this is the root of the path, and they go one of 2 ways. Now, what I mean by one of 2 ways is either they are going to make a late or not. And so we'll define that a late payment, maybe we'll just say L for late, and what state they're from Okay, well, they're either from Four Corners or not from Four Corners. So the state that they're in, we'll just say Four Corners, F for Four Corners, and then F complement would be they're just from somewhere else, not Arizona, Colorado, New Mexico, or Utah. Again, not to worry about exactly where they are from, just that they're not from the Four Corner states. So everybody, if we just said, hey, line up guys, and I want you to take one of these two paths. If you have made a late payment, take the top path. If you haven't made a late payment, take the bottom path. Okay, so that means, and let's just draw kind of like where they end up. So just imagine that these people will walk either this way or they'll walk this way. And well, what do we know? How many of them are going to walk up versus down? Well, 12% of cardholders make a late payment, so we would expect 0.12 of however many people there are here. So if this was 100 people, let's just play with the number 100. It doesn't have to be 100. It doesn't matter because ultimately we're measuring percentages anyway. So 12% would go that way, or 12 people, and then the other 88 would say, well, I don't make a late payment, so I'm going to go to the bottom group. From there, we'll further split them out, right? So notice that these add up to 100% of all people. There's no alien abductions going on, nothing like that. So the people who have made a late payment, still, we'll ask them, okay, if you're from Four Corners, move to the top. If you're not from Four Corners, F complement, move to the bottom. Okay, if they're like, well, I'm from Washington, where do I go? Well, you go down this path because that's not part of the Four Corners. Well, what percentage of these people who are in the L state will travel up to the F state? We know that 25% of people are from the Four Corners, independent of whether or not they make late payments. So we would expect that 25% of these 12 people, right? So if that was 12 people and 25% of them travel this way, then that would amount to 3 people of the 12 would travel up, and then the remaining 75% of those guys would make their way down to, well, I'm not from a Four Corner state. So that would be 9 people go this way, and 3 people go this way. So notice that we're always accounting for our groups. They're just the groups are starting to split off more and more depending on how many branches we have. In this case, we only have 2 sets of branches. And same thing down here for those 88 people that walked and said, I don't make late payments. We'll now ask them, all right, hey, if you're from Four Corners, move to the top. If you're not from the Four Corners, move to the bottom. And we're going to end up with 4 distinct groups. So again, independent of whether or not they make a late payment, 25% of people are from Four Corners and 75% are not. So of these 88 people, 25% will walk this way. And just to give you a number, 25% of 88 is 22 people. Okay. So 22 people will make their way to the top of that 88, and then the other 66 will make their way down to the bottom. So again, notice that at any pair of rungs, they have to add up to 100%. Any pair of rungs, they have to add up to 100%. And everybody who starts off here, the 100 people, or the whole, the 100%, that's why we're really focusing on 100 people, because it's out of 100%, everybody ends up somewhere. So 12% of 25%, this is now a joint probability, 12% of 25%, 25% of people make late payments and they're from the Four Corner state. So that's going to come out to 3%, which notice we could still interpret that as 3 out of 100 people. Of the late payers, 12% or 75% of them, or 0.09, will end up not being from the Four Corner states. So out of the 100 people, 9 people. Notice that they still add up to 0.12, that the total proportion of people that moved up in the first place. And that makes sense because, again, we're assuming no weird things happening, no alien abductions, nothing like that. 25% of these 88% of people, now we'll notice we're multiplying probabilities. These are joint probabilities. the likelihood of having two qualities, not making late payments and being from four corner states, is going to be, we said, 66% of people. And then of that 88%, of those 88 people, 75% do not make late payments. That comes out to, I think I have this backwards. This should be, what did we say? 22, right? Yes, 22. All right, and down here we would have that 0.66. Again, notice that those add up to 0.88. That's the total proportion of people that move downward in the first place. And what should we get when we sum these up? Well, if this is the 12%, this is the 88%, then this should add up always to 100%. That's our 100 people are accounted for. They're in four different categories. These 3%, that's the probability or the percentage of all people who make late payments and who are from the four corner states. These guys are the percentage of all people who make late payments and are not from four corner states. Percentage of people not a late payment and from four corners, and this is the percentage of people not a late payment and not from the four corner states. So those are all the possible outcomes. And now this gives us a map of everything. And even if we don't need all of it, it's all there, and we've done mathematical checks to ensure that all our figures make sense. Okay, let's answer some questions now. What is the probability that a card holder is not from the four corners? Okay, not a trick question. Well, that's going to be 25%, right? Or 75%, because 25% are from the four corners, and then 75% are not. Now, you could also gather that from the end branches here. You just have to ask yourself, are these three people, 0.03, not from four corners? Well, these 3% of people are from the four corners. These 9% are not, so we want to include those guys. These guys are from four corners, these guys are not. So notice that if we add those together, the 0.09 plus the 0.66, what do we get? Well, not surprisingly, we get 0.75. Probability, and that's just the probability that you're from four corners, which we already knew to begin with, but notice that we could actually grab that data from our tree. Let's pick another color here. What is the probability that a randomly chosen cardholder is not from the four corners, but does not make late payments? Okay, well, let's figure out, of these four groups, they don't make late payments. Oh, that's these guys and these guys, but we want them to not be from four corners. That's just these ones here. That's the 0.66. So the probability that you are, and it doesn't matter what order you consider them, and you could say F bar intersect L bar, but I'm just going to keep things even the way we've written it. That's the probability that we want. That's just the 0.66. So you always have to ask yourself, and the key here behind just being able to answer these any types of probability questions is just to ask, who are the people that satisfy these conditions? And I think that makes it a lot easier than having to figure out which formula to try to use. At the end of the day, notice all we're using to build this tree diagram is the joint probability rule. What is the probability that a randomly chosen cardholder is not from the four corner states or does not make late payments? That's the key word here. Or. Okay, what does it mean to say or? To say or if we said A or B, that means just A, not B. That means just B, not A. But it also means you could be both. You could be both of them when you say the word or. And this is one of our misconceptions of the word or. Or means one, just the other, both. Those are your three possibilities for or. And this is something worth memorizing because it pops up so regularly in mathematics. Or means just A, not B, just B, not A, or both A and B. Think about it this way. If you were to go to the college and do some things with your schedule and they needed a picture ID, they said you could either have your driver's license or your student ID. Well, you'll only need one, but if you brought both, they wouldn't tell you, hey, you didn't follow instructions, leave, you have too many forms of ID. The word or allows for the possibility of both. So the one thing that we just need to pay attention to here is the fact that in this case, one, the other, or both kind of involve a not, right? So let's just kind of think about, if you're not from the four corners, you are from somewhere, right? So it is still an action. Just because you're not one thing, you still are something, you're just not from the four corners. If that seems too philosophical, let's just calculate it and see. So let's figure out who is in this group, who is in this group, who is in this group. So let's look at the people who are just four corners, not late payment. So that's going to be the percentage of people who are do not make late payments and who are from the four corners. Okay, do not make late payments and who are from the four corners. You can grab that out of our table. Not late payments are from the four corners, 0.22. Oh, I'm sorry, not from the, yeah, not late payment and are from four corners, that's the 0.22. Okay, so 0.22, they also have those who are not late payments, so that is, they do make late payments, but they have to be one or the other, so that means they are not from the four corners. Okay, so they have to have at least one bar in there. In other words, if you want to really simplify this, as long as one of those events has a bar over it, then it qualifies as not being from the four corners or does not make late payments. Okay, let's figure out what percentage of people this represents. That's going to be our, so we said 0.22 is part of it, and also these 0.09 are part of it. Late payers not from the four corners, 0.09. And lastly, who are both of these things, so they are both not late payers and they are not from the four corners. Again, we can just grab that from our table, and that's going to be that 0.66. So all the ones in orange are all the people who qualify as being in one group or the other group, again, allowing for the possibility of both. Now, because these are different people, right, you can't have the same person in this first group and this group, because that would be a contradiction, right? They can't not be late payers, but simultaneously be late payers, as well as they can't be from the four corners and not be from the four corners. So there's no overlap in these probabilities. So if we simply add these together, if we sum these up, we're going to get what we want, 0.88 plus 0.09. That's going to account for, if my math is correct here, that's going to be the 0.97. Okay, so what we've just found is the probability of A or B. Now I'm going to write a formula, but we didn't need this at all. It just boiled down to some simple computation. It's the percentage of people who are in A and not in B. The percentage plus the percentage of people who are not in A and in B, plus the percentage of people who are in both. Another way, and this is one way you'll often see it in a textbook, is why can't we simply just add the percentage of people who are one plus the percentage of people who are the other? Here, and we just added the people who are not from the four corners. Well, that's already given to us. That's 0.75. And if to that we added the percentage of people who are not late payers, and that is the 0.88, you notice already, hopefully, that this doesn't make sense. You cannot have over 100% of people when you only have 100% of people, of the people that you have, right? So something happened here. Let's go back up here and see why this contradiction occurred. So the percentage of people who are not from the four corners, let's capture them. And what I'm going to do here is we're just going to circle those numbers. So the people who are not from the four corners, that's these guys plus these guys, right? That's our 0.75 that we have down here. That's our 0.75. Then To get this 0.88, that's the percentage of people who do not make late payments. So let's figure out who those people are who do not make late payments. Well, I'll do this in different colors. You can see what happens. That's going to be this 0.22. These guys don't make late payments. But also this 0.66, they don't make late payments either. But that 0.66 is being counted in there twice. It's being counted once for the percentage of people who are not from Four Corners, and then it's being added in again because some of those people who are not from Four Corners also do not make late payments. So that's why we get over 100%, because we have this double count of the 0.66. So I'm going to put down here minus the 0.66, because if this number includes it and this number includes it, then we have to subtract it out one time. We've got that 0.66 in there twice. Now, what does that 0.66 represent? Well, that represents the percentage of people who do both things. And so this probability formula that you might see is you have to subtract off the percentage of people who are in both things, because it gets counted in here once, it gets counted in here once. This gets counted twice, so we need to subtract one of them away, and that's going to give us our 0.75 plus 0.88, and I'm not going to be surprised when we get 0.97, and lo and behold, we get 0.97, which is exactly what we needed. Now, the cool thing is we didn't need this formula because our tree diagram explicitly showed us everything that we needed to see. So, do I recommend using the formula? Well, it can be helpful sometimes if you're trying to solve for one of the elements in the equation, but with a simple tree diagram, you oftentimes don't need it. So, two ways you could calculate the probability of a union. One is there's no overlap among these three, but there is overlap here in the second calculation, and we have to subtract it away once. Let's do one more question, and then we'll end this video. What is the probability someone falls into the category of at least one of the following? So they are in Four Corners, make late payments. So it could be just the people that are in Four Corners, just the people that make late payments, or both. So isn't this really just one or the other? Isn't that exactly the definition? It means one, just the other, potentially both. And so let's again count the people who are in at least one. Running out of colors here, but let's try it with, let's go with pink. All right. So the percentage of people who make late payments, percentage of people who are in Four Corners, who are at least one of those. Well, that's these guys here. Those guys do both. So they do at least one. These guys are late payers, so that's at least one of those two qualities. And these people are from the Four Corners, so that also satisfies the condition that those are people who do at least one of these. Again, these are independent groups, so it's just going to be these three of the four. In fact, notice that the only one that doesn't qualify for at least one is the condition where you are neither of those things. So let me write this down. So this could be the percentage of people who make late payments and are not from the Four Corners, plus the percentage of people who are not from the Four Corners but are, not late payers but are from the Four Corners, plus the people who are both. These are people who satisfy the condition, at least one. Okay, let's add those together. That's going to be, well, wait a minute. That's just going to be everything but this 0.66. So these should add up to 0.34, which notice they do. 0.03 plus 0.09. Let's see. Make sure I get these in the right order. I think 0.22. Yeah, late, and this is the 0.09 plus not late payers and from Four Corners, it's the 0.22, wrote these down in a different order than we have them in the table, so I just have to do a couple double takes here, plus the 0.03. And that comes out to, again, 0.25. This is the 0.34. So that's one way to calculate the probability of at least one. And I'll just write it kind of generically. This is not very mathematical, but it'll give you an idea. Another way you could compute this, the probability of at least one, in general, is 1 minus the probability of neither. Right? So the idea here is that we can take away the people who don't satisfy the condition because there's only one group who do neither of those things or have neither of those characteristics. Yes, we could add up all the ones who do, but imagine that you have a stack of paper, and let's just say the majority of the paper is white paper, printer paper, and you have a couple of pink sheets in there that you need to remove. You could do that one of two ways. You could take all the white sheets and one by one, put them in a separate pile, and then when you get to one of those pink sheets, move them to a different pile, and keep going with the white sheets until you get to the next one. Okay, that is the possibility. Collect all of your white sheets of paper in one pile. That's essentially what we're doing right here. The other possibility is just to reach into that pile, and where you see a pink sheet, just pull those out and separate those from the group that you want to have in the end. And that is basically what we're doing with this formula, is just removing what we don't want. Which one of these two you use is not really essential. Sometimes it's going to be more intuitive to do it this way, and sometimes you'll see, hey, maybe I can do it a little bit more efficiently.